Welcome to ASA Opera Academy's webinar on sustainability with EcoPower and Ecoflex Technology. My name is Russell Corriveau, and I will be your lead instructor today. This session should last around 45 minutes, give or take 10 minutes. During this session, your lines will be muted. However, you can pose questions using the question and answer icon at the bottom of the page. We will reserve time at the end for your questions. This session is being recorded and will be available within 24 hours for your viewing. Also, within 24 hours, you will receive an email as your proof of attendance that can be submitted to your employer or one of the industry association partners such as DHI or ALOA for your industry CEUs in lieu of a certificate of completion for these short trainings. In addition, ASA Opera Academy has over 50 online courses that are all available at no cost. To get started, simply create an ASA Opera account and begin learning at your own pace. Securitron EcoPower is a highly efficient power supply designed to work with low-power electrified locks. Using a patent-pending method, EcoPower reduces the power to 8.5 milliwatts of power, which is a 99% decrease compared to current linear and switching power supplies. EcoPower utilizes a battery to power the door's low-energy electrified lock. It only draws electricity from the wall to charge the battery as needed, usually less than once a day. Securitron EcoPower is designed to work with Corbin Russwin and Sargent's electrified Mortise locks and exit device trims that have Ecoflex technologies. Using Ecoflex locks with EcoPower power supplies can reduce power consumption from 10 watts to a phenomenal 24 milliwatts of power. Low power consumption means that the included EcoFlex battery provides more than 24 hours of backup power. EcoPower is the most efficient, full-feature power supply available today. The EcoFlex locks are so energy efficient that the lock is being powered by the battery most of the time. When the battery drains to a certain point, the EcoPower power supply is activated to recharge the battery. Once the battery is fully charged, the EcoPower power supply turns off, allowing the battery to power the lock, taking the lock completely off the grid until the battery needs to be charged again. Securitron EcoPower specifications: input voltage is 100 volts to 240 volts, allowing for great amount of versatility. The output voltage is 14 volts with a peak amperage of 0.5 amps and a continuous output of 0.1 amps, which is more than enough for any EcoFlex Mortise lock. The EcoPower includes an AGM lead-acid battery. So what's an AGM lead-acid battery? An AGM lead-acid battery is basically the same as a standard lead-acid battery from a technical standpoint, because they use the same basic chemistry. The difference is that the AGM battery uses an absorbent glass mat between the lead lines plates, which wickers the electrolytes solution, keeping it in suspension and not free floating. The AGM batteries are more shock and vibration resistant than standard lead acid batteries. The EcoPower power supply is designed for traditional access control systems and includes the following inputs. It has fire inputs, normally open and normally closed contacts. It has access control inputs with normally open and normally closed contacts. It supports both fail-safe and fail-secure configurations. The LED, there's an LED on it for troubleshooting, and built in is a battery end-of-life notification. So if you ever have an issue with it, when the battery dies, you'll be notified ahead of time. The EcoPower fits a standard double-gang junction box. The hybrid technology allows the battery to power the lock and the reader. And lastly, the EcoPower has the MagnaCare lifetime no-fault replacement warranty, which means it's guaranteed for the life, which is incredible. It's the best warranty on the market. Now we're going to take a moment and look at some of the differences between the EcoPower and a 12-volt 1 amp BPS power supply. Starting with the size, the BPS unit occupies about 72 square inches, opposed to only 16 square inches of wall space. The EcoPower will accept a much larger range, 100 volts to 240 volts, while the BPS unit can only accept 110 plus or minus 10 volts. So it's much more limited. The standby power is the power used by the power supply when the lock is not in use. BPS's 5 watts of standby power is 250 times greater than the standby power of the EcoPower, making it far more energy efficient. The EcoPower also has access control inputs, which the BPS unit does not. Also, the battery is included with the EcoPower, which it is not included with the BPS unit. Basically, the two units end up at the same price, with the EcoPower offering quite a few more benefits. Now, let's examine the use of power for each system. A typical traditional power supply uses about 6 watts of electricity, and a standard solenoid-operated lock or exit device trim also uses about 6 watts of electricity for a total energy usage of 12 watts of electricity per opening. If the solenoid-operated lock was replaced with an Ecoflex Mortise lock, it would only use 0.2 watts of electricity. The entire system would now use only 6.2 watts of electricity in comparison to the 12 watts of a traditional system. Taking it a step further, if the traditional power supply was replaced with an EcoPower power supply, which uses only 0.008 watt, 8.5 watts current, the entire system would now use 0.2085 watts of power compared to the traditional system, which would use 12 watts of power. The traditional system requires 57 times more the power than the EcoPower with the Ecoflex Mortise lock, which is quite a huge difference.
Are you looking to make your building more energy efficient? Today, increasing numbers of architects and designers are taking steps to make their buildings more progressive. At ASSA ABLOY, we are committed to helping reduce environmental impacts through smarter products and advanced production methods. Our Ecoflex technology is a revolutionary innovation for electrified door opening components, such as mortise locks and exit devices. It provides users with solutions that are both energy efficient and secure. Ecoflex's progressive technology is third-party certified by Green Circle. Traditional electrified door solutions use a device called a solenoid, which pulls more energy than needed to lock or open a door. Would you take all of the energy from New York City to power your home? So why use more energy than needed to lock or open your door? With its power-saving design, Ecoflex technology lowers energy consumption by up to 96% versus older solenoid technology. Whether it's for a healthcare, education, commercial, hospitality, or retail building, ASSA ABLOY's Ecoflex technology is always the right fit.
So what is Ecoflex technology? Ecoflex technology dramatically reduces power consumption by up to 96% as certified by Green Circle. The Ecoflex technology incorporates a new actuator to replace the traditional solenoid used in most electromechanical locks. The actuator functions at any voltage from 10 to 30 volts of electricity, which means it can be used with either 12 or 24 volt power supplies. Reduced power consumption is not its only advantage over traditional solenoids. The Ecoflex locks have a peak current draw of 450 milliamps. This means that the power supply which powers the locks can be sized much smaller to reduce energy consumption and increase flexibility. Additionally, with a peak current draw of less than half an amp, the EcoPower is the ideal solution for PoE locks, allowing PoE locks to connect using the PoE locks being powered by Ethernet cables as well as supporting data. So the Ethernet cables will support both power and data with PoE locks, so you don't have to hardwire the locks. Note how the Ecoflex stands up against the Stanley lock, solenoid operated lock, that requires 1.1 amps compared to 0.45 amps of power. Another huge advantage with the Ecoflex technology is that the actuator is field selectable, either fail safe or fail secure, with the use of a toggle switch located in this area right here. The lock is still going to be ordered as fail safe or fail secure. The factory will hand and configure the lock and trim to every customer's specification. As I've mentioned, a traditional solenoid consumes about 6 watts of electricity. This amount of electricity causes levers to heat up and shortens the life of the solenoids. ASSA ABLOY has developed the replacement for the traditional solenoid, which is our Ecoflex technology. This technology draws only a fraction of the power, and since it uses so little energy, it doesn't cause heat rise as the traditional solenoid does. So therefore, you don't have thermal breakdown of the solenoid, and it does extend the life of the product. Here we have a simple example emphasizing the advantages of the Ecoflex mortise lock. In this example, we have 5 doors in the stairwell having fail-safe electrified mortise locks, which allow individuals to re-enter once the fire alarm has been activated. With traditional solenoids, each lock would consume about 6 watts of energy. This results in a total energy consumption of approximately 30 watts of electricity for these 5 doors. If these locks were replaced with Ecoflex mortise locks, the Ecoflex mortise locks consume only 4% of the energy of the traditional solenoid. So the total power consumption for the Ecoflex mortise lock would be reduced to less than 1 amp of power, less than 1 watt of power, actually 0.9 watts of power. Ecoflex allows for longer 24-volt cable runs without negative impact on the lock's function, because the Ecoflex operates between 10 and 30 volts. So even with very long wire runs, you're not going to have the voltage loss that will still prevent the lock from operating, because it only needs 10 volts of power. Ecoflex has received the Green Circle third-party validation, certifying it as energy efficient up to 96%. And Green Circle is a leading provider of third-party sustainability claims and certifications. Here's a little bit more of an explanation on the Ecoflex technology.
Hi, my name is Scott Lauder, and I'm a product manager at ASSA ABLOY in New Haven, Connecticut. And today I'm going to demonstrate for you the new Ecoflex mortise locks that have been developed and released by Sargent and Corbin Russwin. This kit will also be demonstrated. This kit has a variable DC power supply that goes from 0 to 30 volts. The kit has a previous generation traditional solenoid lock, and it also has the equivalent Ecoflex mortise lock. Looking at a traditional solenoid lock, there's many limitations, and those limitations are not only known, but they're accepted in the industry. Those limitations include the fact that they have to be ordered as 12 volt or 24 volt, fail safe or fail secure. If they're specified, ordered, manufactured, shipped, installed, or otherwise in the wrong configuration, the lock would have to be replaced. Additionally, traditional solenoids, this particular one is configured for fail-safe operation at 12 volts. They draw a significant amount of energy. So at 12 volts, this lock is consuming about 350 milliamps of energy continuous. That also causes solenoids to get warm and causes hot levers, but also that heat slowly degrades solenoids in their application. If I took this 12-volt solenoid and I installed it in the real world, where I have a battery backup or something else occurring in the system that causes the voltage to be raised, notice how it affects the current draw as well. Again, heating the solenoid more, utilizing more energy, and eventually breaking down that lock quicker. So we're going to introduce the new Ecoflex mortise lock, which is located over here. As I flip this switch, you'll notice that this lock returns to a fail-safe application, and this one, which is fail-safe, will lock when powered. But most importantly, take a look at the current draw difference between a traditional solenoid and the new Ecoflex at the exact same voltage. The Ecoflex lock is consuming just about 15 milliamps of energy versus over 350 milliamps for a traditional solenoid. So just within Sargent products, previous generation and new generation, we're looking at over a 96% energy improvement from the traditional design to the new Ecoflex design. As I mentioned, this design is currently configured for fail-safe operation, and it's operating at approximately 12 volts. If I turn the voltage up on an Ecoflex lock, though, it will run, and as you can see, consume the same amount of current, whether it's at 12 volts, 24 volts, or even beyond. Just about 30 volts now. The Ecoflex lock is designed to operate at any voltage from 12 to 24, but the real world is beyond that. So it will actually function from 10 to 30 volts. This improves the reliability of any installation, but also if the wrong voltage was specified, the Ecoflex lock can very quickly accommodate that. The next neat thing to show you is the fact that it's not only voltage insensitive, but the new Ecoflex lock also can be very quickly field configured between fail-safe and fail-secure operation, or vice versa. With the use of a pen, not a screwdriver, not voiding our UL or voiding our warranty, you could take a pen and you could change the configuration of this lock very quickly from fail-safe to fail-secure just by flipping a dip switch, which is located on the bottom surface of the lock. Cycling power one time, this lock has now changed its configuration from fail-safe to fail-secure. And as you see, if I apply power, it will unlock, and if I remove power, it will relock. So in quick summary, the Ecoflex lock is much more efficient than a traditional solenoid lock. As I said, approximately 96% more efficient. It also, though, gets rid of the issues associated with traditional solenoids, namely the fact that they must be ordered as fail-safe, fail-secure, 12 volt or 24 volt. Thank you very much for this opportunity to introduce the new Ecoflex Mortise lock to you today.
Now we're going to take a look at the Ecoflex technology and how it has been incorporated into a few of the Sargent and Corbin Russwin hardware products. First, let's take a look at the Sargent 8200 series mortise lock with the Ecoflex technology. One nice thing is that it's completely backwards compatible with existing 8200 series electromechanical lock installations. The Electrolinks connectors have been used by Sargent since 2006, simplifying the installation process and the upgrading process. So all the wires are still in the same location. So the same latch bolt monitoring switches are controlled by the same wire, the request exit, all of that is in the same location. So you can just unplug an old lock and plug in the new Ecoflex lock and it will work perfectly fine, whether it's 12 or 24 volts. And then you can field configure it to either fail-safe or fail-secure. As I mentioned, the actuator is actually field selectable, either fail-safe or fail-secure. You have a small little toggle here at the bottom of the harness to easily change it between the products. And once again, once you've changed it, you need to electrify the lock. You need to cycle the lock once electronically to make it reset itself to the new fail-safe or fail-secure configuration. Taking a closer look at the lock body itself, here is the actuator, and part of the actuator is the request to exit switches. Ecoflex provides the option of request to exit switch to monitor either the inside, the outside, or both the inside and outside levers individually. Now for some of the additional monitoring features that have been incorporated into the 8200 series are, you have deadbolt monitoring located here, so monitors the position of the deadbolt. And of course, deadbolt monitoring is only going to occur when you have a deadbolt. You have guard bolt monitoring. Guard bolt monitoring is the part that prevents the latch bolt from being pushed back, so monitoring the position of the guard bolt. You have latch bolt monitoring, which is the latch bolt itself. You have auxiliary bolt monitoring. Auxiliary bolt is the guarding mechanism that is being held in by the strike when the door is in the closed position. So we're monitoring the auxiliary bolt to make sure that the door is closed and that is being pushed in. And the actuator monitor. So we're actually monitoring. Not only are we telling the actuator to turn on and turn off, we're actually monitoring its position so we have verification that it has changed. The electromechanical blocks from Sargent will still be ordered as they always have been. An 8270 is a fail-safe, an 8271 is a fail-secure with the actuator, locking and unlocking the outside lever handle. And then you also have 8272 and 8273, where the actuator actually locks both the inside and outside lever handles, which is not as commonly used. All four of these functions come standard with key override. The high security monitoring option available with the NAC locks, NAC Mortise locks, can be used as a standalone electrified locks or in conjunction with a wall reader. Every NAC lock will be shipped with a door position switch, a request to exit switch installed. The NAC locks are ordered with Deadbolt, will be supplied with Deadbolt monitoring. So NAC locks are locks that are sold separate from an access control system. In the past, you would buy our electrified locks as part of the access control system, and a number of our customers wanted to buy just the lock body to incorporate into their own systems, and that's an NAC lock. So Network Access Control is NAC, and that's what it stands for. So we sell it that way, with or without Deadbolt and with or without key override. Sargent's electromechanical Ecoflex Mortise lock has a standard black harness on the lock body. Okay, that is standard. And we do have a variety of harnesses because the harness is what's going to change when you change from various technologies. The Ecoflex Mortise lock platform is now available with internal end-of-the-line resistors for comprehensive monitoring of the circuit between the access control system and the lock. Typically, resistors are installed at the panel or above the door, creating vulnerability between the resistors and the lock. Incorporating the resistors within the lock itself eliminates the risk of undetected tampering or damage while reducing installation costs, simplifying specifications, and offering assurance of a factory installed and tested product. At this point, the end-of-line resistors are available with Mercury systems, Linnell systems, Software House, AMAG, access control systems. So how does it work? Let's take a look. So a typical unsupervised access control system. So with a standard access control system with unsupervised line, when the door is in the closed position, the circuit is being completed through the door position switch, and the access control system identifies the door as being in the closed position. Works perfectly fine. When the door is open, the circuit is broken and not complete. The access control system identifies the door as being open. That works fine. The problem comes in is when you have unsupervised lines become compromised or have short circuits in them. Then the access control system identifies the door as being closed because the circuit is being completed through the compromised condition or the short circuit, even when the door is open. When the system is compromised, the door status is unknown and security is lost. And that's the problem with typical access control system with unsupervised lines. Oftentimes, integrators will incorporate end-of-line resistors near the panel where it's easy to install and it's convenient. Taking a look at the end-of-line resistors and how they resolve the problem of unsupervised line, Sargent took the end-of-line resistors and actually incorporated them directly into our harness. So now, as you can see here, this is a blue harness. If you see a blue harness on the back of the Sargent 8200 series Mortise lock, that means this harness has end-of-the-line resistors in it. So let's take a look at how end-of-line resistors solve the problem. Okay, an access control system with supervised lines is far more secure and is most often accomplished by adding resistors within the circuitry to monitor the system's voltage opposed to monitoring either an open or closed circuit. And that's a big difference, is that we're going to be monitoring the voltage opposed to an open or closed circuit. So how does it work? Note that the voltage and resistors used in this example are for clarification of the concept only. Okay? The access control system will specify the voltage and the strength of the resistors for their system. So when the door is in the closed position, the circuit is being completed through the 2R resistor. Electricity takes the path of least resistance to complete the circuit. The access control panel, in this example, is producing 5 volts, and the circuit is being completed through the 2R resistor. 5 volts going through the 2R resistor identifies the door as being in the closed position. When the door is open, the circuit is now being completed through the 3R resistor. the panel is still producing 5 volts, and when the circuit is completed through the 3R resistor, the access control system identifies the door as being opened. That works great. So what happens if it gets short circuit? If the system becomes short circuited, either by mistake or for evil purposes, the panel will continue to produce 5 volts and identifying that the completed circuit has bypassed both of the resistors and that there is an issue that needs to be resolved and the door status open and close is unknown because the system's been short circuited. The nice thing with the supervised lines, you know immediately that it's been short circuited and you have an issue that needs to be resolved. If someone cuts the wires or they become disconnected, the panel will produce 5 volts, but the access control system will identify that's an incomplete circuit and it's not receiving any current back. And once again, we know that there's an issue that needs to be resolved and we do not know the status of the door. And that's how end-of-line resistors solve the problem. So as we said, integrators normally incorporate them above the ceiling. We actually incorporated them right into the lock body, so they're well protected and there are no issues. And they're going to be located right here within the lock body, which is inside of the door. I'm just going to point out a few other new features that we have for our 8200 series. This is a deadbolt privacy function. The way this works is when the deadbolt is extended, it disables the remote access control system. So the card reader or the keypad or a timer cannot unlock the door. So when the deadbolt is extended, the access control system is turned off. Only when the deadbolt is retracted is the access control system functional. This prevents one person from walking in on another. This is ideal for personal and privacy areas, such as nursing room, on-call doctor rooms, restrooms, and shower areas. This is specified as a PHR. This is actually quite amazing. What Sargent has done here, they've actually incorporated a door position switch directly into the lock body. As you probably know, door position switches are normally located at the top of the door. What Sargent has done is put a door position switch into the lock front, and on the back side of the strike, they've placed 2 magnets. And now in series, they're going to monitor the door position switch, the latch bolt, and the guard bolt to verify that the door is closed, because the door position switch is saying the door is closed, the latch bolt is extended, and the guard bolt is pushed in, verifying that the door is closed and secure. This is specified as an IDP. Corbin Russwin also has incorporated the Ecoflex mortise lock into their ML2000 series mortise lock. And it's with Corbin Russwin, between the ML2000, so when you see a 9 or a 6, that means it's going to be an electrified lock. So when you see an ML2900 and ML2060, those are electrified locks from Corbin Russwin. It has all the same features as all the Ecoflex technology does, which means it will operate on 12 or 24 volts right out of the box, has a very low current draw of only 15 milliamps and a peak current draw of less than half an amp. And once again, the ML2900 series is field selectable as either fail safe or fail secure, but you will still be ordering them as fail safe or fail secure. What we're showing you here is these are different options from Corbin Russwin. So here you have a single cylinder on the outside. This option has no cylinder at all. Some of them lock both levers, some of them lock one lever. So you identify it as fail safe or fail secure by the ASF. So that would stand for fail safe. And then if you wanted fail secure, you're using the exact same part numbers, such as ML2906, ML2906. You need to specify SEC for fail secure and SAF for fail safe. But they do offer the most variety of mortise lock versions out there. Okay. Corbin Russwin mortise locks are also available with the request to exit switch, which will monitor the lever handles. And this is specified as an N92 option. And this can be purchased with the new Ecoflex mortise locks or with the mechanical mortise locks if you don't need an electrified mortise locks. Okay. When it comes to latch bolt monitoring, Corbin Russwin also offers latch bolt monitoring, and that is specified as an M91, so position of the latch bolt. And another feature they offer, which is quite interesting, is 105. With Corbin Russwin, the M105 Quick Code offers door positioning status within the lock body itself by monitoring the latch bolt and the dead latch, which is in series, to make sure the door is closed and latched. It's a little different than the Sargent does, but it does a pretty nice job also. Corbin Russwin also offers the NAC lock, Network Access Control Locks, as an ML2600. They do offer it in a number of configurations, and these high security locks, these high security locks will come standard with request exit switches, the door position switch, and the NAC locks will be ordered with deadbolt, will be supplied with deadbolt monitoring. So you can get them with deadbolt or without deadbolts. And once again, you're going to be specifying fail-safe or fail-secure to specify which one you prefer. These are all fail-safe, while these are the fail-secure versions, and the part numbers are the same, ML2606. End-of-line resistors are also available with the ML2000 series. They offer the same end-of-line resistors as Sargent does with Mercury and Linnell systems, Software House, and AMAG. The Corbin Russwin Mortise lock is also available with the privacy deadbolt function. The privacy deadbolt function operates in this manner, as we said. When the deadbolt is extended, it disables the access control system, preventing the access control system from unlocking the door with a keypad or a card reader or a scheduled unlock. Once again, ideal for personal and privacy area, nurses' call rooms, restrooms, and such. This is specified as a PHR. If you're not aware of it, the electromechanical warranty for both Sargent and Corbin Russwin is 2 years, and the mechanical warranty on their Mortise locks is 10 years. Now we're going to take a quick look at the Ecoflex technology within the exit devices. So Sargent has incorporated the Ecoflex technology into the Sargent 700 series electromechanical ET control with the Ecoflex technology. The ET control is still going to be ordered as fail-safe or fail-secure, but can be easily reconfigured in the field with one switch that's located right here. So all you need to do is move this switch over to change it from fail-safe to fail-secure, but you will still be ordering it as a fail-safe or fail-secure. Keep in mind, with Sargent, fail-safe and fail-secure is specified by the function number. You're not calling out ASF or SEC. Now, just for a moment, let's just take a look at what it takes our competition to change their locks from fail-safe to fail-secure on their exit device trim. This is the way they show it in the video. With theirs, since they don't use an actuator, their solenoid actually has to be taken out of the lock completely and flipped over to work in the opposite direction. Much more complicated than either Sargent or Corbin Russwin. And then you have to try to reassemble the whole assembly, which doesn't look that easy. Just with all Ecoflex products, the ET control is fully functional on 12 or 24 volts right out of the box and has a full wave rectifier in it. So it will allow either DC or AC current to be used. Once again, if you're looking for latch bolt monitoring, you can get latch bolt monitoring. Start again. If you're looking for lever monitoring, you want to monitor the outside lever, you can get that from Sargent, and that's specified as a 54 dash to monitor the outside lever. Corbin Russwin has also electrified their 900 series trim, and when it's electrified, it becomes a 9900 series electrified trim. Okay, so they've also incorporated it. Once again, it's field selectable, either fail-safe or fail-secure. And right here, there's a little switch right in this area here, and that's how you switch it from fail-safe to fail-secure with the 900 series trim. Keep in mind, with Corbin Russwin's 900 series trim, they handle it a little bit different than the Mortise locks. Here, the function number is determining if it's a fail-safe or a fail-secure. So a 9903 is fail-safe and a 9905 is fail-secure. Keep in mind, both of these come with key override as standard, and the exit devices always allow free egress. The voltage requirements is the same because it's an Ecoflex technology. So anytime you hear Ecoflex, it will operate on 12 or 24 volts. The exit device trim has a built-in rectifier, so it can handle either AC or DC current. And keep in mind, with the Corbin Russwin trim, this trim is freewheeling trim, which means when it's locked, it still rotates as an anti-vandal feature. A unique feature that Corbin Russwin offers with the 900 series trim is the security monitoring feature. This is a single pole double throw switch that monitors the position of the motor actuator to tell the trim if it's locked or unlocked. So you can't get lever monitoring with the Corbin Russwin trim because they have freewheeling trim and it always rotates, so the lever monitoring would not be advantageous. So they put it on the actuator so you know when it's locked and when it's not locked, which works out quite well. One nice thing with all of the ASSA ABLOY products, with the Ecoflex and everything, they all come with the Electrolinks connectors. And these are Molex connectors. These are available anywhere, but all ASSA ABLOY products come, or all electromechanical products come with Molex connectors. Here's a little bit more on it.
Electrolinks. Electrolinks is the easy answer to hardwiring issues. It's a system of universal plug-in connectors with standardized color-coded wiring that makes installation a snap. This standardization ensures that the products of all Door Security Solutions Group companies work together. Doors, hinges, and frames are delivered pre-wired. There's no need to match up wires, create connections, or drill any holes. With Electrolinks, installing electrified openings is a snap. First, you connect power to the pre-wired frame. A conduit built into the frame carries power to the pre-wired hinge. The hinge serves as a bridge to carry power to the pre-wired door. Now, whatever electrified hardware you put on the door just has to be plugged in. Later, if your security needs require more sophisticated access control systems, just swap out the previous component and plug in the new one. There's no need to retrofit the entire opening, which could risk altering your fire rating. What used to be a complex job for an electrician is now like plugging in a telephone. Installing electrified openings is fast, convenient, foolproof, and future-proof, making it easy for you to secure facilities and keep people safe. Electrolinks, hardwiring made easy.
And if you're not aware of it, ASSA ABLOY and Sargent has had this since 2006, which has been quite a long time. And now even our major competitor now produces quick connect connectors because it's worked out so well and it was such a great idea. Just so you know, with the Electrolinks connector system, female connectors are used on all hardware and hinges, while male connectors are used on the harnesses. So the harnesses are the parts, so male harnesses are the parts that go through the door. So that would be a harness, so that would have a male connector. The pigtail here that's going up to the power supply, that would also be, but the hinges is going to have female connectors, and so is the hardware going to have female connectors. Pre-wired doors with Electrolinks connectors are available through Seco, Curry's, and Barron. These pre-wired doors will have 12 wires going through them, one with an 8-pin connector and a 4-pin Electrolinks connector. Makes it much easier to wire up any product. And that brings us to the end of our presentation. Just a quick summary, the Ecoflex technology is a major breakthrough in architectural hardware, offers greater efficiency, flexibility, and reliability for the same price for the equivalent function sold previously. Efficiency helps meet sustainability objectives, offering a 96% reduction in energy usage, ideal for fail-safe applications such as stairwells, reduces the number of power supplies required, as well as the load on each power supply. It's very flexible. The single lock can be used for multiple needs, field configurable and operates on 12 or 24 volts, and very, very dependable. Eliminates the risk of voltage drops or induction kickbacks because it allows so much variation in voltage and such. And that basically brings us to the end of our presentation. I'm going to open this up to see if you have any questions. Thank you very much for attending today's presentation, and I hope you have a great weekend.